Hello guys, in this video we are going to discuss the solution of the problem smallest window in a string containing all the characters of another string. So let us look at the problem statement. The problem statement says given two string s and p, find the smallest window in the string s consisting of all the characters including duplicates of the string p. Return -1 in case there is no such window present. In case there are multiple such windows of same length, return the one with the least starting index. So for instance, if this is the string which is given to us and this is the another string which is given to us, and as we can see, the substring toprac, which is this part of the string s, contains all characters of string p, because of which we are returning this, and this is the smallest window in the string s. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the string which is given to us, and within this string we want to find out the minimum window length in which all characters of string p exist. So let us see how we will be able to do that. So in order to do this, what we are going to do is we are going to take a dictionary. So let us say we have a dictionary p1, and this dictionary contains all the characters of string p. So these are the characters which are present in string p and their frequency. So t has occurred once, o has occurred once, and c has occurred once. So this is how the dictionary will look like, and we will also take a variable count which will hold the information on how many characters of p has been matched in s. So to begin with, the value will be set to 0, and now we will start iterating on s. So we are going to take a pointer and we are going to set it over here, and we are going to set I to 0, and then we are going to check whether this character, so s of I or s of 0, exists in p1 or not. Since s of 0 exists in p1, so that simply means it is a match, because of which we are going to increase our count by 1. So count becomes equals to 1. And at the same time, what we are going to do is we are going to create another dictionary, which is s1, which contains the information of what all characters we have observed so far and what is its frequency. So far we have observed just t, and the frequency of t is 1, and we will keep updating these dictionary. So let me just summarize this. So to begin with, we have a dictionary p1, also we will have a dictionary s1, and we will have a variable count. Now let us proceed forward. So after operating on 0th index, we are going to move our index to the next position. So this will come over here. At this position I is equals to 1, and as we can see, s of 1, which is equals to I, is not present in the string p, and this search we can do it in order of one time because the string p we have converted it into a dictionary. Now since I does not exist in string p, because of which count remains equals to 1, but we are going to add an entry over here. So I is what we have encountered, and the frequency by which I has encountered is 1. Now we'll move to the next index. So I is equals to 2, and at 2 again m is encountered, so the same thing will happen. So m will come over here and count will remain as it is, and the same goes for e as well. So now we are at this position, so the value of I is equals to 3, and s of 3 is equals to e, and since e does not exist in the string p, because of which count remains equals to 1, and we are going to make an entry over here. Now let's move to the next character. The next character is t, so we are at I equals to 4, s of 4 is equals to t. Now since t exists in the string p, but the frequency of this t is 1, and in dictionary s1 we already have a value of t which is equals to 1. So what we are going to do in this case, count value will not be increased, so count remains equals to 1. And why the value of count is not getting increased? Because in the string p, t has occurred just once, and in the string s, so far we have encountered t twice, and of those two occurrences of t, we just have to count one occurrence, because of which count will remain 1 and t over here will get increased to 2. Now let's move forward. So the next character is O. So we are at I equals to 5, and S of 5 is equals to O. since O exists in the string P, because of which we are going to increase our count by 1. So now count becomes equals to 2 and O entry will come over here. Now I is equals to 6, so now we are at the next index where the value is equals to P. Again, P does not exist in string P, because of which count remains equals to 2 and P comes over here. Again, we move to the next index, and as we can see, R and A does not exist in the string P, because of which R will come over here and A will come over here, but the value of count will remain equals to 1. So now we are at the 9th index, count will be equals to 2. Now we are at this index, which is 10th index. So the value of I is equals to 10. S of 10 is equals to C. And as we can see, C exists in the string P, because of which we are going to increase our count by 1. So count will becomes equals to 3 and C entry will come over here. Now as soon as we have matched all the characters, so remember this count stored the values of the characters which we have matched so far. So as soon as we have matched all the characters, so as we can see, the length of the string P is equals to 3 and the value of count is also equals to 3. So as soon as we matched all the characters of string P, our next objective is to minimize the window. So let us discuss how we will be able to minimize the window. So far we know that the window in which all characters exist is this window. So this is the starting point of that window and this is the end point of that window. And the P1 dictionary is this. I have just arranged it in this format. So TOC is the pattern which we are trying to match and the corresponding frequency. So T occurs once, O occurs once and C occurs once. And this is the S1 dictionary which we have built up. So T in this window occurs twice and all other characters occurs once. Now let us see how we will be able to minimize it. So we will be able to minimize the window length if either of these two conditions are satisfied. So the first condition is character in window does not exist in pattern. So what do I mean by this? Well, if we take these characters such as I, M and E, these characters does not exist in pattern. So if possible, we will go ahead and remove these characters from our window, and in that way we will be able to reduce our window length. So that is first condition. The second condition is a character in window exists in pattern, but the frequency of that character is greater than the frequency of that character in pattern. So let me explain this. So in order to understand this, let's take the character T. The character T, we are expecting it to occur once in the window, whereas as we can see, it has occurred more than once. So 2 times it has occurred. Since it has occurred 2 times, so we are at the liberty of removing one of the T's from our window. So using these two conditions, let us see how we will be able to minimize it. So the first character which we are observing is T. Since T falls in the condition of second, so we should be able to minimize our window length, which simply means it is possible to move our starting point to this position, because T, we want T to occur once, but T has occurred twice. So this occurrence of T, we can skip it. So now T becomes equals to 1, or the occurrence of T becomes equals to 1. And in this way, as you can see, we are minimizing the window length. Now I, M and E, all these characters we can escape because they belong to the first condition. Since they are not there in the pattern, so we can confidently skip these characters. So these characters will be gone from our window. Now we are at this position. Now T, we want it to occur once, and the current frequency of T is 1, because of which we are going to keep it. So in this way, the minimum length window which we are able to find out is this window, which is T, O, P, R, A and C, and this is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to return the smallest window. A string S and a string P is given to us. So the first thing which we'll check is if length of P is greater than length of S. If this is the case, then it is not possible to find a window, because of which we are going to return -1. Otherwise, we are going to take two dictionary S1, which is equals to 0, and similarly, we are going to take another dictionary P1, which is the same thing. So 256 characters and all the initial value is 0. And we are going to take a variable count. Initial value is equals to 0. J, which is the starting of window, initial value is equals to 0. Minimum length, initial value we are going to set it to positive infinity. And the starting IDX, index, initial value is equals to -1. Now we are going to build our dictionary P1. So let us build that. So for ch in string P, P1 of order of ch equals to, we are going to increase it by 1. So the initial value was 0 and then we are going to increase it by 1. So essentially we are building our P dictionary, and if we stick with the same example, then the dictionary, then after this loop the dictionary will look something like this. So T will become equals to 1, O will become equals to 1, and C will become equals to 1. After this we are going to iterate on the string S. So for that, for I in range of len of S. So the first thing which we are going to do is build our S1 dictionary. So the same thing, order of ch plus equals to 1. How many times ch has occurred so far is what we are maintaining it over here. Now we are going to check whether S of I, so this character, matches in the pattern or not. So if P1 order of S of I is not equals to 0, then that simply means that the character S1 exists in P1. If it is equals to 0, then that simply means it has not occurred in the pattern. Since it is not equals to 0, then it has occurred in the pattern. So that is the first condition. And the second condition which we are going to ensure is how many times does this character Si occurs in S1. So if S1 order of ch is less than or equals to P1 order of, this is instead of ch, this is S of I. If this is the case, then we are going to increase our count by 1. So with this condition, we are trying to capture this case, which is T. So T has occurred twice so far. As we can see, T has occurred twice so far. And how many times do we want T to occur? Well, the number of times we want T to occur is just 1. Since T has already occurred once, because of which we have not increased our count by 1, or the count remains as it is. So the same thing is what we are trying to achieve over here. So if this is the first occurrence of T, then we are going to increase our count by 1. If T has occurred more than once, then we will not increase the value of T. So this is our 11th part. And then the next part is we are going to check if count equals to len of P, which simply means we have matched all the characters of string P. In such case, our objective is now to minimize the window. So let us discuss the pseudocode for minimizing the window. So to do that, all we have to do is while P1 order of S of J equals to 0. So J is, so remember we took a J over here, and the initial value of J is equals to 0, which is the starting point of the window. So if the starting character of the window does not exist in the string P, so in such case this P1 value of that particular character will be equals to 0. So in such case we will shrink the window. So by shrinking we will increase our J pointer, or S1 order of S of J is greater than P1 order of S of J. So we are discussing this case where the frequency of T is 2 and we just want it to be matched once. In such case, it is possible to skip this T. So this is what so this condition ensures that if, let me call this as C1 condition. If C1 condition is satisfied, then we have to update this value as well. So S1 order of S of J, we are going to decrease it by 1. Recall from this discussion, this 2 was getting decreased by 1. So that is what we are trying to do over there. And then towards the end, we are going to increase our J by 1. So far we have decreased or we have shrink our window length. So let us now compute the length of the window. So the length of the window will be given by I minus j plus 1. Now if this length is less than minimum length, then in such case we are going to update our minimum length. So minimum length equals to length, and let us update our starting IDX. Well, the starting IDX will be given by j, and towards the end all we have to do is we have to check if start IDX was not updated. So in such case the value will be equals to -1. If it is not updated, then that simply means we were not able to find any window, because of which we are going to return -1. Otherwise we are going to return the substring. So the substring will be given by the starting index, start IDX, and then the length of the substring. So start IDX plus minimum length. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So the first thing which we are checking is if the length of pattern is greater than the length of a string, then we are returning -1, because in such case it is not possible to find the window. Otherwise we are taking an S1 dictionary and a P1 dictionary, and the first thing which we are doing is we are updating our P1 dictionary. Once we have updated our P1 dictionary, then we are iterating on I for I in range of len of s, and then over there we are updating our S1 dictionary. Then we are checking whether this character exists in the pattern or not, and if it exists in the pattern, it occurs for the number of times we are expecting it to occur. So for instance, we want it to occur for one time, and if it is occurring for more than one time, then in such case we will not increase our count. Otherwise, if it occurs for the number of times we want it to occur, then we will increase the count by 1. Then the next case is if count equals to length of p, which simply means we have matched all the characters in p. In such case we are attempting to minimize the window length. To do so, we are checking whether the starting character of window does not exist in pattern. If it does not exist in pattern, then we can shrink the window by 1, or if the starting character of window, the number of time it should occur is greater than the number of time it has actually occurred, in such case again we will be able to shrink our window. So we are shrinking our window, and we are also updating this counter, this value, and towards the end we are computing the minimum length, and we are updating our start IDX. And towards the end, if start IDX equals to -1, then we are returning -1, otherwise we are returning the substring. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. If length of pattern is greater than length of string, then we are returning -1. Otherwise we are taking P1 and S1 dictionary, and then we are updating the P1 dictionary. After updating the P1 dictionary, we are iterating on the string s, and we are updating our S1 dictionary. If the SI character exists in pattern and the number of times it occurs in the pattern is less than or equals to the number of times it is in the pattern, then in such case we are increasing our count. If count is equals to p dot length, that simply means we have matched all the characters. In such case we are attempting to reduce the length of the window. After reducing the length of the window, which will be done by this loop, we are computing the minimum length, and towards the end we are checking if start index equals to -1, then return -1, otherwise return the substring. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.